Let's look at how some of this stuff with the mean value theorem and signs applies to a specific graphing problem. Again, graphing is never the solution, but it can lead to the solution. And so I want to look at this function here. I'm sorry, it's not a function. It's an equation. Y squared is x cubed minus 36x. It's not a function because for any particular x, you'd have two values of y. And for a function, you can only have one. So we're going to have to deal with this one implicitly. And we're going to minimize the amount of algebra that we have to do, and we're going to focus on the signs. So the first thing we're going to do is take the derivative of each side. We're going to have to use the chain rule because y is a function, and so y squared is a composition. That's the function y and then squared. And so when you take the derivative of that, you have 2y prime. Derivative of squaring is doubling, but then the chain rule says you have to have this factor of the derivative of what's inside. That's the 2 scoops of raisins per package, 12 packages per carton deal. And then the derivative of x cubed minus 36x is more straightforward. That's 3x squared minus 36. And so that is what we get from the doing the derivative implicitly. And let's see, we can pull some factors out of here. So this is 3 times x squared minus 12, and well, that factor is 3 times x minus square root of 12, x plus square root of 12. Square root of 12 is between 3 and 4. We're going to need that in a second. So, so now we can see what's going on with the sign of the derivative. So we'll solve for y prime, and we find that y prime is equal to, I'll use the unfactored part on top. So it's a fraction. The bottom is 2y. The top is 3 times x squared minus 12. And so there it is. Now, we can look at the signs of these things. But first, actually, let's come back and look at the sign of the original function. So I'm going to bring that down over here. We've got y squared is x cubed minus 36x. That's the thing that we were given. And there's a problem here. You got to think about signs. And when you think about signs, there's a problem. The left-hand side is positive. So that means the right-hand side has to be positive. So what you have to do is look at where this cubic has is positive. If the cubic is negative, there are no possible solutions in here. You can't have a negative equal to a positive, and y squared is positive. So the cubic factors as x, x minus 6, x plus 6. And so when we start to think about what's going on with the graph of this thing, we're not going to be able to say exactly what's going on. But something happens at minus 6 and at plus 6. So remember, this is a cubic. So here's the basic shape. All cubics have that shape. And the roots are at minus 6, 0, and 6. You should have studied this in pre-calculus, but you probably didn't. Basic cubic, it's the right side up, and we know what the roots are because it was easy enough to factor. And so now we know where this cubic is negative, there are no solutions. So if x is less than minus 6, this is going to be empty. And if x is between 0 and 6, this region is going to be empty. So I'm kind of hashing those out. So the only solutions we're going to have in this to solving this equation are going to be in this strip here and then everything off to the right. Okay. So now if we go back to the derivative, we only need to worry about what happens between minus 6 and 0 and between 6 and infinity. And so so there's the situation. So the derivative is we're going to have a situation like this. So I'm going to kind of duplicate what I did earlier. and we're going to look at the signs. Y is positive, y is negative. X squared minus 12 is positive, x squared minus 12 is negative. Actually, let's take care of that right now. Here's the graph of y equals x squared minus 12. It's a right side up parabola. This is like one of the basic shapes, and this is why we do the basic shapes. And then we know what the roots are, and so we have this situation with minus square root of 12 and square root of 12. So this will tell you the sign of the top of the derivative, and y will tell you the sign of the bottom of the derivative. Okay, so interesting things happen. Let's see. Nothing happens until minus 6. So so we're going to have some stuff starting at minus 6, and then we're going to go to 0. And there's some stuff between minus 6 and 0. And then we're going to go to 6. And now we're just going to start doing pieces of what's going on. In this quadrant, what we have is y is positive, and the parabola, the bottom, is positive, and so that we have that y prime is positive, so y is increasing. Below the axis, we still have the same sign for the top of the derivative. The top of the derivative is that parabola x squared minus 6, but now y is negative. So now when y is negative, y prime becomes negative, and so y is decreasing. This is the area where nothing happens. So we'll just write here be dragons. There's nothing there. And then to the right, 6 is bigger than square root of 12. So as far as one part of the derivative, the top part, that's positive. And so this will have, the derivative has the same sign as y. So we're going to have that y is increasing, y prime is positive, so y is increasing. Y prime is positive, so y is increasing. And then y is decreasing. And so that's going to pretty much settle what's going on with this thing. We've just looked at the signs. Y is positive, y is negative. We've got the parabola, and we can see where the parabola is above the x-axis, and we can see where the parabola is below the x-axis, and that tells us the sign. We don't care about the values in this situation. We just care about the signs. Okay. So now we can start to fill in the graph, and it's kind of satisfying. First of all, when we're graphing this thing here, when x is minus 6, then y is 0. So that gives us this point I've done in red, and then there are two branches to this, and when y is positive, y is increasing. When y is positive, y is decreasing. Those are the two implicit functions, and that happens right up until we hit minus square root of 12. So I'm going to put that in. So I've added in this dotted thing as a guide. And at minus square root of 12, the upper branch, where y is positive, is going to change from increasing to decreasing. Change from increasing to decreasing, that's a maximum. And so we're seeing a maximum there. And then the opposite thing happens with y below. Y is decreasing, then changes, y prime changes sign, so y becomes increasing. So we get this, and then to the right here, the square root of 12 thing is in Dragonland, so that got burned alive. And so all we have is that y is increasing, y is decreasing. It goes through this point, and so we're getting a graph that looks like this. As in this upper branch, y is increasing, and so that's an increasing function. It's an implicit function, but it's increasing. This lower branch, y is decreasing. It's implicit. It's an implicit function. It's the lower branch. It's where y is negative, and that's what makes y prime negative. And so there it is. There's the graph. and we're pretty much going to be able to say a lot. That's more than you thought you might have been able to say when we started with this, and it all depended on signs and the mean value theorem. It's not the mean all value theorem. It's really useful. If y prime is positive, then y is increasing. And we're going to use this to look at differential equations. We'll use this in the tangent line approximation and start to look at some honest models.